Welcome to our channel. Today we're diving into the heart of our solar system with 10 mind-blowing facts about the Sun. That blazing ball of plasma that keeps us all alive. We think we know it, right? It's up there keeping us warm, giving us light. But trust me, the Sun is far stranger, far more fascinating than you might think. We're going to peel back the layers of this celestial giant and uncover the secrets within. So buckle up, space cadets, because you're about to get a cosmic education. You know how we look at planets, moons, even stars, and we see these beautiful spheres hanging in the vastness of space? Well, the Sun takes it to a whole new level. You see, the Sun is one of the roundest objects we've ever found in the universe. Imagine that, this giant ball of fire, millions of miles across, and it's almost perfectly spherical. Now you might be thinking, big deal, planets are round too, but the Sun, it's not solid like a planet, it's a churning, boiling ocean of plasma, constantly in motion, yet despite all that chaos, gravity holds it together, pulling it inwards, smoothing out any bumps or irregularities. It's a delicate dance between the outward force of nuclear fusion and the inward pull of gravity. And the result? This almost impossibly perfect sphere, a cosmic testament to the power of the fundamental forces of the universe, makes you realize, even in all that chaos, there's an underlying order, a beauty that's hard to comprehend. But that's the universe for you, always full of surprises. So what is the Sun actually made of? You might be surprised to learn it's mostly just two simple elements, hydrogen and helium. That's right, the same stuff we use to fill balloons here on Earth is powering that giant star in the sky. About 74% of the Sun's mass is hydrogen and about 24% is helium. That remaining 2%, it's a sprinkle of heavier elements like oxygen, carbon, neon and iron. Think of it like the cosmic spice rack, adding a little flavor to the mix. But here's where it gets really interesting. The Sun is like a giant cosmic furnace, constantly fusing hydrogen atoms together to create helium. This process, called nuclear fusion, releases an incredible amount of energy. The energy that lights up our solar system and keeps us all alive. It's like the Sun is a giant power plant, fueled by the most basic elements in the universe. Now let's take a journey to the heart of our star, to a place where the pressure is unimaginable and the heat is beyond extreme. Let's journey to the Sun's core. Here temperatures soar to a mind-boggling 15 million degrees Celsius. To put that in perspective, that's over 2,000 times hotter than the surface of the Sun, which is already hot enough to vaporize most known materials. Deep within this inferno, something incredible is happening: nuclear fusion. Imagine hydrogen atoms, the smallest atoms in the universe, smashing together with such force that they fuse, creating helium and releasing a tremendous amount of energy. This is the engine of the Sun, the source of its power. It's a continuous process, a cosmic dance of particles. And it's been going on for billions of years. Every second, millions of tons of hydrogen are converted into helium in the Sun's core, releasing the energy that allows life to flourish here on Earth. It's a humbling thought, isn't it? That our very existence is dependent on this distant, fiery furnace. You know, even stars have a beginning, and the Sun, our Sun, is no different. It wasn't just there one day, it had to form, to be born. Picture this: a vast, cold, dark cloud of gas and dust, what astronomers call a molecular cloud. These clouds are like stellar nurseries, and this particular one, billions of years ago, was about to give birth to our Sun. Now gravity, the sculptor of the cosmos, is always at work, and it began to pull this cloud inward, causing it to collapse in on itself. As it collapsed, it spun faster and faster, like a figure skater pulling their arms in, and at the center of this swirling cloud, the temperature and pressure skyrocketed. Then, boom! The core, this dense ball of hydrogen, ignited. Nuclear fusion began, and our Sun, as we know it, burst into existence. It was a violent, chaotic birth, but from that chaos came the anchor of our solar system, the giver of light and life. It's a story that's been playing out across the universe for billions of years, and it's still happening today. We've talked about the Sun's birth, but like all things, even stars have a lifespan. Don't worry, this isn't happening anytime soon. But billions of years from now, our Sun will undergo a dramatic transformation. It will leave the familiar main sequence of its life and enter a new phase, becoming what astronomers call a red giant. As the sun burns through its hydrogen fuel, its core will contract and heat up. This will cause its outer layers to expand outward, engulfing the inner planets, including, sadly, Earth. The sun will balloon in size, becoming hundreds of times larger than it is today. Imagine that in the sky, a giant red sun dominating the heavens. But this giant won't be as scorching as you might think. Even though it will be much larger, the sun's outer layers will actually cool, giving it a reddish hue, hence the name red giant. It's a stage of stellar evolution that most stars go through, and it's a reminder that even the most constant things in our universe are subject to change. But hey, we've got billions of years to prepare, right? Have you ever wondered what keeps all the planets in our solar system from just flying off into the vastness of space? Why don't we just spin away into the darkness? Well, it's all thanks to the sun's incredible gravity. You see, the sun isn't just the center of our solar system in terms of location. It's the anchor, the gravitational glue holding everything together. Think of it like this. Imagine a bowling ball in the center of a trampoline, and that bowling ball is our sun. Now roll some marbles around the trampoline, and those marbles represent the planets. The marbles will circle the bowling ball, right? That's because the bowling ball's weight warps the trampoline, creating a dip that the marbles fall into, but their own momentum keeps them circling. That's gravity at work. The sun's massive size means it has a very strong gravitational pull. This pull is what keeps all the planets, asteroids, and comets in our solar system orbiting around it in a kind of cosmic ballet, all choreographed by the sun's unseen hand. We ventured into the heart of the sun, where temperatures reach millions of degrees, but even its surface is nothing to sneeze at. We're talking about the photosphere, the part of the sun we actually see from Earth. Now, you might be surprised to learn that the surface is much cooler than the core, but cooler is a relative term here. The sun's photosphere has a temperature of about 5,500 degrees Celsius, or about 9,932 degrees Fahrenheit. To put that in perspective, that's hot enough to vaporize most metals instantly. It's the reason why the sun shines so brightly, emitting light and heat that travel millions of miles across space to reach us here on Earth. Think about that the next time you feel the sun's warmth on your skin. You're literally feeling the energy that traveled millions of miles across the emptiness of space, all the way from the surface of a star. It's a powerful reminder of our connection to the cosmos and how even from such a vast distance the sun's influence is felt here on our little planet. The sun may seem calm and constant from our vantage point on Earth, but it's actually a very active and dynamic star. It's constantly releasing a stream of charged particles into space, a phenomenon we call solar wind. Imagine it like the sun's breath, a constant outward flow of energy and matter. This solar wind originates from the sun's corona, the outermost part of its atmosphere. The corona is superheated to millions of degrees, and this extreme heat causes particles to escape the sun's gravity and fly off into space at incredible speeds. These particles, mostly protons and electrons, travel at speeds of up to 1,000,000 miles per hour. Now, this solar wind might sound dangerous, and it can be. When it interacts with Earth's magnetic field, it can create beautiful auroras, but it can also disrupt satellites and even power grids. But it's also a testament to the sun's power and influence, a reminder that its reach extends far beyond the visible disk we see in the sky. We all know that light travels incredibly fast, but even at the speed of light, it still takes time for the sun's rays to reach us here on Earth. In fact, it takes about 8 minutes for sunlight to travel the 93 million miles from the sun to our planet. Think about that for a second. When you step outside on a sunny day and feel the warmth of the sun on your face, you're actually experiencing sunlight that left the sun 8 minutes ago. You're looking back in time. It's a mind-bending concept, but it's true. This delay in light travel, what we call light travel time, is a fundamental aspect of astronomy. It means that when we observe distant objects in space, we're seeing them as they were in the past. The farther away an object is, the farther back in time we're looking. So, in a way, astronomy is like time travel, allowing us to peer into the distant past. We've explored many fascinating facts about the sun, but here's one that really puts its size into perspective. The sun accounts for a whopping 99.86% of the total mass of our entire solar system. That's right, practically all of the matter in our solar system is contained within that blazing ball of plasma. To put that into perspective, imagine you had a giant scale. On one side you put the sun. On the other side you put everything else, all the planets, moons, asteroids, comets, dust and gas. The sun would still outweigh everything else combined by a factor of over 500. This incredible mass is what gives the sun its immense gravitational pull, the force that holds our entire solar system together. It's a humbling reminder that we're just a small part of a much larger system, all orbiting around a star that dwarfs us in every way. Thanks for watching. If you enjoyed these sun facts, don't forget to like, subscribe, and hit the bell icon for more amazing content. So, the next time you see the sun in the sky, take a moment to appreciate its power, its complexity, and its vital role in our lives. It's more than just a bright light in the sky. It's a cosmic wonder, a giant nuclear furnace, and the anchor of our little corner of the universe. Keep looking up, keep asking questions, and never stop exploring the wonders of the cosmos.